Hey everybody, in this video we are going to continue with solving some logarithmic equations. But in this example, we are going to take it a little bit further. Now, normally I would go into examples using quotient property and then it would still be a logarithmic form like strategy 1 that I would change into exponential form, yada yada. However, let's jazz it up and we're going to go into strategy 2 where we will condense our logarithms using things like power property, quotient property, product property, but then we'll be able to use the one-to-one property to ignore log and just work with whatever's on the inside, whatever is the inner function. So let's see that in action by looking here at example 8. On the left side of example 8, I'm going to use the quotient property, and that means I will end up with the ln, or natural log of, and I have a quotient here, x plus 2 in my numerator and 4x plus 3 in my denominator. And the right side is sort of going to get not touched at all, and I'll get ln of 1 over x just the way it is. Now I have an ln, or natural log, on each side. Because ln, or natural log of x, logarithmic, or even exponential are one-to-one functions, I can ignore the ln, or the natural log, and just set the inner portions equal to each other because there is only one input for each output and vice versa. So I can just solve from here. Lovely. I'm going to multiply both sides by x, and you are not dividing by ln, by the way. Please never say that or think that. It is not a thing. Don't embarrass yourself, okay? I'm also going to multiply 4x plus 3 on each side. Some of you might think of this as cross multiplication. I hate saying that because people use it at the wrong time and place, so I'm just pretending that's not happening. 4x plus 3 will reduce with 4x plus 3. On the left, I'll have x times x plus 2. I got x squared plus 2x equals, and on the right, I have 4x plus 3. Now, I went from having a logarithmic equation to having an adorable quadratic equation. Yay! Is it as great as a linear? No, but it's still pretty good. Now don't forget, when it comes to solving logarithmic equations, you want to make sure you check for extraneous solutions, because log, you cannot take the log or ln of a negative or of 0. So you want to make sure that when you plug your answers back in, since the domain of a polynomial is all real numbers, we're going to get maybe more answers that work for this. We want to make sure they're still comparable to the original problem. Okie dokie, okie dokie. So how do I solve a polynomial? I get it equal to 0, of course, silly goose. So if I subtract 4x, I have x squared minus 2x, right? I subtracted 4x, and I subtract 3 minus 3 is 0. 1 away. This is the style of quadratic the SAT tends to like. But x and x, I'm going to use 3 and 1. It's got to multiply to give me negative 3 and add to give me negative 2. So minus and plus will go right there. Now we use what we call the zero product property. And from here, we will set each factor equal to 0. Only works when it's equal to 0. X equals negative 1. And x minus 3 is 0. So x is 3. Now check it back into the original. Like if I filled negative 1 in here, negative 1 plus 2 is 1, so that's fine. But I run into a problem because negative 1's not so hot later on for other parts. So extraneous, plug in the 3, I get 5, you're cool. I get 15, you're cool. I get 1/3, you're cool. So oops. So the x equals 3 is cool. Dunzeroni. And let's do one more for good measure. Same idea, the left side, ln x minus 3 equals ln of 7x minus 23 over x plus 1. We're going to ignore, for all the reasons I already explained. I'm going to multiply x plus 1 to that side. That'll give me, I'm going to FOIL because I'm a smart student, first, outer, inner, last, x squared plus 5x minus 3x minus 3 equals 7x minus 23. Let's combine like terms and get it. Oops, squared. Let's combine like terms and get it equal to 0 while we're at it. So x squared. This is negative 2x. Take the 7x over. Negative 2x minus 7x is minus 9x. Negative 3 plus 23 is plus 20 equals 0. There we go. We got our quadratic. Adorable. We love it. Factor 4 and 5 minus minus equals 0. Zero product property. I get x equals 4 and x equals 5. Check for extraneous solutions. If I fill in the 4, I don't get a negative anywhere, so you seem okie dokie. And I fill in 3. I'm not 3, what am I saying? 5. And yeah, you look cool too. I think they're both good. See, we don't have to have an extraneous. We could have two very happy, wonderful, working. Alice, you're walking on my keyboard. Do you mind? That was rude. That just gonna yawn at me. And that's it. So I hope that this helped you. If you feel better about this kind of example, great. I'm happy for you. Thumbs up. Mark your territory that you watched this video. Well, not you, Dallas. And thumbs down if you're still confused, or questions, comments, concerns, requests, or feedback in the comment section. If you need a specific example, by all means, type it out and I will make a video on that if I get a request. No problemo. And check the playlist in the thumbnail on the screen now, or check the description box for more. Bye for now. Adios.